Okay, hi again. We just went over the homework. One thing that I wanted to note as far as some physical properties of alkanes, or alkenes for that matter, or alkynes, as far as boiling point and melting point. Now, if I've got CH4, which is only one carbon, and that's methane. If I've only got one of those, one carbon, and then I wanted to compare it to the boiling point of ethane, which one do you think would have a higher boiling point? Well, think about it. This one is propane. Now, you can see that these are all in the same homologous series, which was a couple videos ago. Basically, this is C to the N, H to the 2N, okay, plus 2. C to the N, H to the 2N plus 2, and that's in your CRT. So, if I have more and more carbons, think about what's happening between the molecules. Okay, we call those the intermolecular forces. So between one methane and another, or between one propane and another. Basically, the rule is the greater the number of atoms there are, the greater the size of the molecule, in other words, the more chances of them interacting with each other with those things we call London dispersion factors. Okay? In other words, there will be more attraction between a bigger molecule and another big molecule compared to smaller molecules. They have fewer atoms and therefore have fewer electrons, and the attraction won't be as great. So from top to bottom, the boiling point is going to go up. Okay? It's going to go up. And therefore the melting point, the boiling points here are pretty low, and this one actually is in the negative range. And you know liquid propane, right? It's shipped as a liquid, but as soon as it comes into your house, it's automatically a gas because its boiling point is very, very quick. Okay? So this would also have a higher vapor pressure because there's less holding those molecules together. Higher vapor pressure and a much lower boiling point. Okay, just wanted to bring that in. All right? Okay, see if you can, why don't you pause and see if you can name these. Okay, so remember on these, I have to also, since these are substituent groups, remember substituent groups are those groups that take the place of a carbon. These substituent groups are going to have to be named in alphabetical order as well. Okay, so let's take a look at this one. Well, we've got chlorine and fluorine. So the C comes first. So it's also going to determine what my numbering is. So since chloro comes first, I'm going to go 1, 2, 3, 4. So that makes this 2 chloro, 2 chloro, 3 fluoro, 3 didn't work, fluoro, and my longest chain here is 4, which is butane. 2 chloro, 3 fluoro, butane. All right, let's try this one. Let me switch colors here. Actually, I'm going to erase this to get more room. All right, how about this one? Chloro and fluoro on the same carbon. So it's 2 each time, right? So this one's 2-chloro. I still start with the one that's lower alphabetically, and 2-fluoro. And it's still butane. Now, one thing I did this on purpose. These two things have the same chemical formula. They would have the same molecular formula. Okay? But they are structurally different. Because of that, these two are isomers of each other. So just to recap, isomers. Isomers are those molecules that have the same molecular formula. If I were to count out the number of carbons, chlorines and fluorines and hydrogens, they would have the same as that one. And since they have the same molecular formula, but the position of the atoms is different. This one went from 3 to a 2, right? Shifted over here. Since they have the same molecular formula but a different structural formula, we call them isomers. So I should be able to give you a structural formula or a molecular formula, and you should be able to build an isomer or more of one or more isomers of that. Okay, so hopefully you tried this one. This carbon goes with this. So what comes first, bromine or methyl? Well, bromine comes first, yes? So what number is this? Do I go 1, 2, 3, 4, 5, or do I go 1, 2, 3? Well, my combination from right to left is lower, so that's what I'm going to use. So this is 1, 2, 3, 4, 5. So I'm calling this 2-bromo, 3-methyl, and what's my long? 5 is pentane. 2-bromo, 3-methyl pentane. Okay? All right. Regents Review Book pages 200 to 201, odds. Okay, I just posted the answers for the evens from page 197 and 198. I want you to check those against what you already have, and then post on the stream if you have any questions about them, and then I can do a video on it. All right? Tomorrow we will start learning about alkenes and alkynes, and then we'll have some homework that will go with that. Okay? All right. Stay sane. Bye.